Hi everyone, this is Mrs. Robinson. I just worked with you on day 3 notes, 1.1.3. Now I'm back for more, day 4, solving systems of equations. So let's talk about a system of linear equations. So that is a set of linear equations. Very exciting. That share the same variables. Okay? So a set could be something like 3x plus 2y equals 10, and 4x minus 6y equals 20. So they both have an x and they both have a y. So they work together to figure out what those solutions would be. A solution to a system would be a solution that works for a solution that works for all equations, for all linear equations. So it has to work for both of them. And so if we had x and y, that it's the point where they connect. All right? So think about when you talk to your friends about what classes you guys have, and think about, okay, what do you have third period compared to what I have third period? So what if we both had the same third period? That would be our solution because we have that in common. Okay? So if you obtain a false equation, meaning you solve it and you get something like 5 equals 8, that means all your variables went away. Then this system has no solution, meaning that they do not intersect at any point. So you and your friend check each other's schedules and you have no classes in common, therefore you would have no solution. If you obtain an identity equation, meaning it's the exact same thing on both sides, but again, the variables disappear, then the system has infinitely many solutions. Infinitely, spelling, infinitely many solutions, also known as IMS. Okay, we don't want to say all real numbers because that's actually not the case. We want to say infinitely many solutions. So now let's go over what these would actually look like. So we're going to graph 3 separate graphs on what different solutions will look like. Now I want to apologize for those of you who printed off the notes. Just add these somewhere on the notes on the side. I just want to give you guys examples. I'm a visual learner, so I definitely want to give you that. So if you had a one solution situation, meaning you graph this system and you want to see where they intersect. So what it's going to look like is you're going to have one line and then you'll have another line somewhere. What your solution will be is where they intersect. Again, who do you have class with? That one class, and then that's one intersection. So that would be known as a one solution for your system of equations. The second one we talked to about that false equation, remember that 5 equals 8. Like, what is going on here? So that what that means is that, again, you have no classes alike with a person. Okay, so that would mean that they had the same slope, but they started in 2 different places. So they're never going to intersect. Okay, so that's known as a no solution when you graphed it. And the last one, and again, I'm sorry, I apologize, my slopes aren't perfect. I'm just going a little bit fast just as a quick reminder, quick recap. And then the last one, if it was 3 equals 3, that would mean you would have all classes with this person. So again, we want to say infinitely many solutions because it's all the solutions that they share on this point. Okay? We don't want to say all real numbers because then that would mean that this point could be a solution, which it isn't because it's not on the line. So that's why we say IMS, which means any points on these lines that they share could be a solution. So if you shared an entire schedule with a friend, that would mean you had every single class together. One of your solutions could be, oh, our 4th period is the same. All right, so let's actually get to graphing and give you an example. So I have y equals 2x plus 3, and I have y equals negative 3x minus 2. All right, so it's awesome. It's already in it's already in slope-intercept form, as we talked about last class. Y equals mx plus b. So think about what is your b and what is your slope. So the first one, we start off at the 3. Our starting point is our y-intercept. All right. Okay, and then I'm going to rise 2 and run 1. I ran out of room, so I'm going to go the opposite way, and I'm going to graph this line. It's really important in systems, guys, is to graph it all the way across the graph. You don't want to just make 2 points on there. You don't want just 2 points on there, and then you'll be like, it doesn't graph together. Well, you need to see the whole line. Lines go on forever. All right, the next one, I have y equals negative 3x minus 2, so I'm going to start off at the negative 2. I'm going to rise 3, 1, 2, 3, and run 1 to the left. Rise 1, 2, 3, and to the left. And so we can already see, bada bing, where do they cross? Okay, so what is that point? That point is negative 1, 1. So negative 1, 1 would be our point and our solution. That would be our solution to our graph. Okay. Now I want you on your own to try another one, and I am not going to put it in slope-intercept form, because I want you to practice isolating that y, so then you can first do that and then graph it. So I want you to graph these two, graph this system of equations, and find the point of intersection. So you can always pause the video, work it out, and then check the solution. All right, welcome back. You should have gotten as a solution 1, 5. So again, if you have any questions, please talk to your teacher the next day. Say Mrs. Robson gave us an extra example, and we would be happy to help you out. All right, now the next examples are solving by substitution. You're not always going to get a system where you're going to graph it every single time. Numbers like 136, I'm not going to be graphing that, so we need to use a different method. There's how many different ways to get to Reno High School? It's the same with solving systems. There's many different ways to get there, and it's your job to figure out what method we should be using. So, substitution. Well, what happens if I am gone for the day? Well, you have a substitute teacher. So that's substitution. We are going to be substituting one section to another. Okay, so what is happening in this one? X is already by itself. So what I can do is I can substitute this section, that whole thing, into X for the other one. What we're trying to do is solve for one of the variables, plug it back in to find the other one. Again, our main objective is to find that x, y. Where are they intersecting? What is going on here? So it's always good in math to say, okay, what is the question and what do they want? What is my end game? My end game is to get x, y. That is my end game. So how do I rock this out? So I have to the x into the second equation, because these two distribute that. So I have 24y minus 32 minus 3y equals 136. Now I'm going to combine like terms. So 24y minus 3y is 21y minus 32 equals 136. Bring over the 32. 21y equals 168. And then divide 21 to both sides. We'd get y equals 8. So work that out. And then from here, so pause this now if you need to rewrite or write this all down. So you can always pause and come back in. So now we have y equals 8. Okay, so what can we do? We can plug that in for y. So x equals 3 times 8 minus 4. And we can figure out what x is. So then I have 24 minus 4. Therefore, x equals 20. Now the beauty about this is, remember, this solution has to work for both equations. Again, what do you have in common with another friend of yours? What class do you have in common? It has to work for both, or we got to start over and see what's happening. Something really important. We definitely should be doing this on our test. Check your work. So 136. So I have 8 times 20, which is 160 minus 24, and we should get 136. So then it works for both. All right, awesome. So that is our solution using substitution. All right, now it is your turn to try out a problem by using substitution. Okay, so I have 3x minus y equals 142 and x minus 2y equals 134. So we got to look at this and see which one do we want to get by itself. Okay, in this problem, if we wanted to get y by itself, we would have to subtract 3x and then divide by -1. In this problem, we would just have to add 2y to both sides. So I'm actually going to do that one. Either way, whichever one you substitute, it should work. Again, when you create that solution, it should work. So there's more than one method to do this. All right, so we're going to focus on where am I plugging that in? The x equals 2y plus 132. So I'm going to plug this into the other equation. We have to work together. They have to work together in order to solve this thing. Okay, minus y equals 142. So you know you set it up if there's only one variable left. If there's 2 variables still in the equation, something's up because you can't solve it. You can only solve one at a time. Okay, so I'd like you to try this out and solve for y. All right, so if you did this correctly, make sure you distributed and combined like terms. You should have gotten y equals -52. Now, with the y equals -52, you can plug it back into either of the originals and find out what x is. So let's go, we can do x minus 2 times -52 equals 134. And solve it and find x. And you should have gotten x equals 30. So what is my solution? My solution is 30, -52. So again, this is a system that I would not be graphing. I'm not going to be graphing to -52. This is something I would use substitution. Next lesson, you're going to be using elimination. So then you can see all 3 methods. So thank you for joining me on Unit 1.4 and hope you're having a great day.